Warm greetings. Welcome for online video session on operating system. Myself Jagadish, Canara Engineering College, Associate Professor, Department of Computer Science. In the last video sessions, we have saw module 1 and module 2. In this session, we'll see module 3. The module 3, the first chapter is on deadlocks. So in the module 3, it covers system modules, deadlock characterization, methods for handling deadlocks, deadlock prevention, deadlock avoidance, deadlock detection, and recovery from deadlocks. So these are the topics that we'll cover in the third module, first chapter. So next we'll see the definition of deadlock. A process requests a resources. So there will be a number of processes. If the resources are not available at that time, the process enters a waiting state. A process requests resources. If the resources are not available at that time, the process enters a waiting state. So sometimes a waiting process is never again able to change state. Waiting process is never again able to change state because the resources it has requested are held by other waiting process. This situation is called deadlock. There will be number of process. So process P1, process P2, process P3. So these are the three processes are requesting a resources, something like CPU time or maybe a memory or maybe a input output file. If these resources are not available at that time, so this process, see, one more process will be there called P4. P4 is holding all these resources. The process enters a waiting state. So no other process like P1 or P2 or P3, all these three processes won't get the resources which is requested by these three processes because it is held by another process called P4. Okay, sometimes a waiting process. So you can see in this picture which are the waiting process. All these three processes are all waiting for these resources. So all these three processes are waiting for the resources which is held by the other process. Waiting process is never again able to change the state because the resources it has requested are held by other waiting process. It won't change the state. Why? Because the resources it has requested, maybe P1 may be requested input output file, P2 may requested for memory, P3 may be requested for some other resources like CPU cycle time. It has requested, it won't change the state because the process, the resources it has requested by are held by other waiting process. So it won't change the, or it won't change the states which is already been waiting in the queue. This situation is called a deadlock. Did you understood? So we'll see the coming slides a correct picture how it works. A system consisting of finite number of resources. A system consisting of finite number of resources distributed among number of competing process. A system consists of finite number of resources. There will be a finite number of resources like R1, R2, etc. Rm, finite number of resources to be distributed among number of process. Like from P1, P2, there will be number of process will be there. The resources are partitioned into several types, each consisting of number of identical instances. So, for example, R1 is a resources. In this R1 resources, there will be number of instances. For example, in this resources, you have 3 instances, like partition. So each resources is being partitioned into three parts. So each part may be given to one resource, one process. So this part it may be given to the process P1, this part may be given to the process P2, and this may be given to the process P3. Such like that, the each resources is being partitioned into several type. Memory space, CPU cycles, files, and input output devices are examples of resource types. So this we have seen in the last slide. So what are maybe the resources type? It may be anything, but they have given one small example like memory space, CPU cycles, files, and input output devices. A process must request, process like P1, P2, P3, etc. must request resources before using it. Something like before the process requesting any resources or making use of any of the resources has to request before using it. Something like whenever the students entering the classroom during the lecturing, the student can't enter the classroom without requesting the concerned lecturer. The same way, before the resources making use of any of the before making use of the resources, any processor making use of the resources, it has to request a permission from the concerned resources. If it wants to make use of any of the instances, these are all called as instances. So resource has been divided into number of instances. Process, if it is before making any use of the instances, the process which are waiting has to request the resources. A process may request as many as resources as it requires, depending upon the process before completion of the work or before completion of its task. It requires a many number of resources. So before completion of its task, it requires many number of resources. Many resources as it requires carrying out its designated task. If any of the resource process, if it is designated to complete any of the task, it requires a many resources. So that resources has to be taken from the permission. Before making use of any of the resources, it has to take a permission from concerned resources or resource owner. The number of resources requested may not exceed the total number of resources available in the system. So in a system you may have around 30 resources, and this is, I'm giving just an example. So in a system there may be 30 resources. So any of the process, if the process, if it is designated to complete any of the tasks, it has to make use of the resources which is available in the system. It cannot, like for example, if it is wants to complete its task, it requires a 30 resources. It cannot ask 35, because the system is having available only the 30 30 resources. It cannot expect more than that. So it has to complete within the designated resources which is available in the system. Resource types R1, R2, and maybe till infinitely Rm. CPU cycles, memory space, input output devices are the examples of the resource types. Each resource type is been designated as a Ri, as Wi instances. So I have shown in this diagram. So this is Ri, and each one of the instances will call it as Wi, Wi plus 1, Wi plus 2. So we call this as a Wi, and this we call it as a Wi plus 1, and this we call it as a Wi plus 2. And some other textbook may use some other notation, and depending upon the author. Okay, so this is what the system modules. So once again we'll finish it off in brushing what actually system consisting of a finite number of resources. There will be number of resources will be there in the system. Depending upon that resource types, the availability of the resources, the process has to request the resources, the resource types which is available in the system. Not more than that, the resource type cannot expect. Okay, and so process type cannot expect. Process must request the resources before using it is. So before making use of any of the resources, the process has to request the permission from the resource type. So if it wants to make use of any of the instances of that particular resources, it has to ask the permission from the concerned resource type to complete to the designated work. And resource type have been assigned R1, R2, Rm, and examples memory space, input output devices, and each resource types will be assigned like Ri, and as instances Wi. Each process utilize resources as follows. So process P1, P2, P3, like there will be number of process will utilize the resources as follows. It make use of the resources as follows. So they can ask in the examination how the process utilize the resources, what are the steps have been taken. So one is request, second one is use, and release. First you request the resources or requested resources to release any of particular instances. After releasing or making use of that resources instances, you use it. Then after using, you release. Why you have to release? So that the other process which is being requested, that particular instances can make use of that instance resource instances. So one is request, second one is use, third one is release. Request, the process requests the resources. Process requests the resources. If the request cannot be granted immediately, why it cannot be granted immediately? Because the process or the resources will be, number of instances will be held by the other process. If the process P1 requests the resources R1, but that instances is already held by the P2 and P3, so it cannot grant immediately. Then the process has to request the concerned resource type to release the, when it get releases, please allocate the resource to the particular resources. Then the requesting process must wait until it acquire the resources. So P1 has to wait in the waiting queue to till P2 P3 releases its resources. Understood? Try to understand once again. Process P1 requesting the resources of R1, but R1 resources are held by process P2 and process P3. So immediately it cannot grant the resources to the P1. Then at that time it has to wait until the resources R1 is been released by the process P3 and P2 and P3. So after completion of the resource is designated task, so there is no need of holding the resources by the particular process. So once it is been completed, it has to terminate its process. So before terminating, it has to releases the resources which is held by that particular process. Use, the process can operate on the resources. Process can operate on the resources. So whenever the resources are being allocated to the process, so when it get allocated the process, or whatever the process is required to complete its task, if it is get, so it has to make use of that resources by that particular process to complete its task. So for to complete P1 it requires R1, R2, R3. So when it gets all these three resources for P1, then it can make use of the all the resources to complete its task. Okay, when it completes its task, then it releases. So release the process release the resources. When P1 is complete its work, then all these three resources will be released back to the system. There will be system where on multiple resources will be there. So I have told as an example, there will be number of resources for each resources for each system. Maybe 30 resources will be available. This is not just an telling an example. So once it releases all its resources which is held by that particular process, it releases resources to the system pool, that is resource type pool. So any of the process request can make use of the resources. So these are the steps, or the that is process has to follow before making use of the resources. One is request, second one is use, third one is release. Yes, yes. So next we'll go on to the next, that is deadlock characterization. So we saw the definition of deadlock. Then what are the characterization of the particular deadlock? There are four conditions hold simultaneously whenever process occurs a deadlock. Deadlock can arise if four conditions hold simultaneously. So process, when we say it has got deadlock, process P1, if all these four holds simultaneously, then we can say the process at deadlock. Deadlock means there is no other steps. So something like it cannot passes through this line. If any deadlock occurs, it cannot passes through this line, it has to come back. So that's what it has to passes this line means, it has to, no, it should not be in the deadlock condition. If the deadlock condition means it cannot complete its task, it has to come back. So that is what. So one is mutual exclusion, hold and wait, no pre-emission, circular wait. Mutual exclusion, hold and wait, no pre-emission, circular wait. So and this especially the deadlocks in the module 3. Very important question, important topic, as well as most expected questions. And there is a very interesting problems will be come across. And so try to concentrate on this theory part, which will more useful for to solve your problems in the coming classes. Mutual exclusion: only one process at a time can use resources. Mutual exclusion: only one process at a time can use a resources. Usually, so there will be number of resources available in the system. If P1 make use of the resources R1, then P2 cannot make use of the resources R1 is here, so P1 is making use of resources R1, so P2 cannot make use of the resources R1. It has to wait. So at that time it cannot occur any deadlock. If the P2 is also making use of R1, so then it is then definitely deadlock occurs. Understood? See here, R1 will have a number of two instances. These two instances will be held by the process P1, and process P2 cannot hold or cannot request. It can request, but it cannot hold these R1 instances. It has to wait in the queue. Then the deadlock won't occur. Hold and wait. A process holding at least one resources is waiting to acquire additional resources held by the other process. Process holding at least one resources is waiting to acquire additional resources held by other process. So P2 is holding R2 resources. It already holding, but to complete its task, P2 complete its task, it requires R1 and R2. But R1 is held by P1, but P2 is already holding the resources P2. That is R2 is held by P2, but to complete its task, it requires R1. So then only, that's what hold and wait. It already mean hold R2 is already held by P2. So why it is holding? Because if it releases the R2, then some other process may hold this R2. So then once P1 is completed its task, it releases R1, it can hold. Then if it is R2 is not held by P2, then it has to wait other process has to release R2 before. Instead of that, since R2 is already available freely, so it can hold this something like a reservation is already done. Something you require another one more seat, so you may in the waiting state. So if any of the due to some reason the passenger won't travel means, then you will be in the queue means, so that seat will be released by the passenger means you can hold that seat, something related like that. Okay, so since you have one seat, you can already book that. It's a confirmation that that seat is already held by you, so there is no need of waiting once again. So you require one more seat, but since you will be in the waiting queue, if the passenger doesn't want to travel on that day, he can cancel that seat, or then that particular the seat which is released by the, okay, there is a passenger which is cancelled, you can hold that seat. So you require two seats, then you got the two seat, something related like that. Okay, no pre-emission. A resources can be released only voluntarily by the process holding it. After that, process has completed its task. No pre-emission. For example, P1 and P2 are the two resources. So both are friends. Resources will be one resources. So since it has been held by the P1, and since both are friends, it cannot ask please release your resources so I can complete my task, something it can't like that. So it has to complete its task, then only it can release the resources. Then resources can process can hold these resources. Voluntarily, it won't be released. The process cannot release the resources voluntarily. Before completion, after completion of the task only, it can release us. Circular wait. There exists a set of process P0, P1, Pn of waiting process such that P naught is waiting for resources that is held by P1. P1 is waiting for resources that is held by P2, and so on. Pn minus 1 is waiting for a resources that is held by Pn, and Pn is waiting for resources that is held by P naught. So circular waiting, if you have studied your data structures in the third semester, how the queue works, and ordinary queue and circular queue. So circular queue something related like this. Okay, seeing that P naught is represented here, and P1 and P2, P3, P4. Okay, so P naught is waiting for the resources that is held by the P1. P1 is waiting for the resources which is held by the P2. P2 is waiting for the resources which is held by the P3, and P3 is waiting for the resources which is held by the P4, and P4 is waiting for the resources which is held by the P0. Circularing wait. So circular wait. Okay, this is what the characterization of the deadlock. So before completion of the work of the that is before the deadlock can arises, it has to hold four conditions. One is mutual exclusion, hold and wait, no pre-emission, circular wait. Okay, so all these four conditions occur simultaneously, then only deadlock occurs, otherwise no. Okay, mutual exclusion, hold and wait, no pre-emission, circular wait. So they can ask in the examination, what are the characterization of deadlocks? So you should represent all these four conditions. So next we'll see the resource allocation graph. A set of resources or set of vertices represented as capital V, and set of edges is represented by capital E. V is partitioned into two types. So capital V partitioned into two types. One is P and R. P is represented as a process, R is represented as a resource types. P1, P2, Pn, set of the consisting of all the process in the system, set consisting of all the resource types in the system, R equals to R1, R2, Rm. So it is represented M, and this is represented as a M. Okay, requested edge, directed edge. So requested means it's a direct edge. Pi requesting Rj resources. Pi requesting Rj resources. Something like P1 is requesting R2 resources. Assignment edges, direct edge. Assignment means Rj is already assigned to process Pi. Something like R2 is already assigned to process P2. Okay, see, P1 is requesting edges like this. Okay, process requesting the resources R2. Assignment means R2 is already assigned to the process P2. So this is requesting P1 is requesting resources R2, but R2 is already assigned, means R2 is already making use by the P2. So these are the, you can please go through this. If you have any confusion, you can see once again. I'm telling the requested hedge, that is process requesting to the resources. Process requesting to the resources is called requested edge. Assignment edge, resources assigned to process. Resource assigned to process called assignment edge. Resources already is been making use by that particular resources. So that is assignment edge and requested edge. I hope I have been clear very clearly. Resource allocation graph, how it been given the notation. So we'll come across. Yeah, of course, notation is one more here. For process, will represented big O, that is circle process. Resource type with 4 instances. So resources R1, it has 4 instances. It means resources R1 is divided into 4 parts, and each part may be required by the, for example, this part is required only for the process 1 to complete, and this may required by process P2, and this may require process 3, and this may required by process 4, and all these resources instances may required by other process P6. So it's like that. Okay, so resource type with 4 instances is represented like this, and some resources may have only 2 instances, and some resources may have 3 instances, and some resources may have only 1 instances. So depending upon, but if it is this is for the representation of the 4 instances. So this is how they are represented. Some resources may have only 1 instances. Pi request instances of Rj. Pi, so process is represented by circle Pi or P1. Example, requesting means requesting hedge, is requesting edge and resources Rj. Okay, Pi is holding an instances of Rj, means Pi, that is process 1, is hold the resources 1 instances of the resources R1. So this is how it is going to be represented. So process, it is represented by big circle. Resource type with 4 instances is represented a square box with 4 instances, and I shown even if it resources having 1 instances, you can represent it like small dot. If it has 2 instances, you can represent it 2 dots. If it is 3 instances of particular resources, you can represent 3 dots. Pi is holding an instances of Rj. So this is already holding this, Pi is holding these resources Rj, and Pi requests instances of Rj. Pi is requesting these resources Rj. So this is how represents the allocation graph. So we'll see next how the instances, there's a graph allocation is done for the particular resources and the resource type. Example of resource allocation graph. Example of resource allocation graph. You can see a process are represented by circle P1, P2, P3. Resource R1, R3, R2 and R4. Process represented by a set P1, P2, P3. P1, P2, P3 is represented by in a set 3 process. How many resources? Resources are represented R1, R2, R3, R4. 4 instances, 4 resources. And hedges, you can see a direct hedge, that is requested edge as well as assignment edge. Requested hedge, that is P1 is requesting R1, Next, P2 requesting R3, requesting P2 requesting R3, P1 is requesting R1, then any other. So P1 is requesting, and P3 is not at all requesting any three, but resources R3 is holding, that is assigning to process P3. Okay, so you can see that for resources 1 and resources 3 having only one instances, and resources R2 it has a two instances. In that, one instances is held by the P1 and another instances is holding by the assigning to the P2. So these two instances are making use of by the process P1 and process P2. Okay, as well as P1 is requesting for the resources R1, but R1 is already assigned to the P2. So P2 is requesting R3, but R3 is assigned to P3. So P3 is not at all requesting any resources, but it is assigned only one resources. So once it's complete its task, P3 can release us R3, and P2 which is requesting can make use of the P2, because P1 cannot complete its task because P1 is requesting the resources R1, but P2 it already assigned two resources, that is R2 one instances and R1 is already assigned to the P2. If P3 releases, then it can complete P2, then after P2 complete it releases the R1, then it can make use of the R1, then it completes its task. So you can see here resources instances, one instances of resources type R1, two instances of resources type R2, one instances of resources type R3. You can see R3 it having only one, and R1 it has a only one instances, and R2 it has a two instances, and R3 it has a three instances of resource type R4. So this is resources examples of resource allocation graph, and yeah, we'll complete this, and we can end up this session. Okay, yeah, example of resource allocation graph, that's process states. Process P1 is holding an instances of resource type R2 and is waiting for the resource instances of a resource type R1, as I showed here. So it's holding one instances and requesting for the another one instances by one instance of R1, but which is already held by the P2. It cannot release us by the P2 because it is before completion of this P3, then only you can make use of these resources. Process P2 is holding an instances of R1 and instances of R2 and is waiting for the instance R3. Process P3 is holding the instances of R3 because only one instance is there, so it is holding. Okay, yeah. By this we'll complete this online video session, ending up this resource allocation graph. So we'll take one more example in the next online video session, and thank you. You can, if you have any doubt, you can ask in the online video session. Thank you all.